This is Sukruti Joshi. Our today's topic for our video session is halogenation and hydration. So here we will take a look on two different organic processes along with its mechanism, that is hydrogenation and halogenation. It also includes here different types of fluorinations, iodinations, brominations and all. So let's move ahead with it. First one is hydrogenation. So the term hydrogenation is referred as the chemical reaction of the substance with hydrogen molecule in the presence of catalyst. This process is performed by either simple adding the hydrogen molecule, that is also known as hydrogenation, or reaction molecule is cleaved by hydrogen. So as you can see in the image, 1 butane is converted in the presence of platinum catalyst. So hydrogenation occurs with 2H2. So 1 butane will react with 2H2 in the presence of platinum. Hydrogenation occurs and it will convert itself into butane. So that triple bond is removed and two different parts of hydrogen will be added to it. So this is basically a kind of addition reaction, right? So it's a kind of organic process in which only and only addition will be done. Now let's see another example of hydrogenation, because it plays a very important role in different organic processes to get different important products. Okay. So as you can see here, we have benzene. Benzene will react with 3 parts of H2 in the presence of platinum. So here hydrogenation occurs and the double bonds are break down. The double bonds are totally down, or they will be breaked, and hydrogens are attached to that particular carbon. So now what will happen when you attach that hydrogens? So it will convert itself into a cyclic structure. So cyclic structure here we get is cyclohexane. So benzene will be converted to cyclohexane in this particular way. If we talk about another example, we get here propanaldehyde. So Ca3CH2CHO reacts with, or basically Raney-nickel in the presence of Raney-nickel. Here the catalyst is Raney-nickel, hydrogenation is done and it will convert itself into 1-propanol. So propanaldehyde will get converted itself into propanol or 1-propanol. So as you can see here, addition of hydrogen is done. That's why it is known as hydrogenation. And here what will happen? Generally that it will occur or it will be done in the presence of specific catalysts only. Okay. Now let's move ahead to the next one, which is halogenation. Very important organic process. So halogenation is either a substitution reaction in which one or more hydrogen atoms in an organic compound is replaced by halogen atoms, or an addition reaction that introduces 2 or more halogen atoms to an organic compound. Okay, so what we will do here, it's basically a substitution reaction in which hydrogen is removed while halogen is added to the particular group. Okay, so it's basically a kind of nucleophilic substitution reaction in which we add nucleophile to our compound. Halogenation reactions generally occurs through chlorine, bromine, iodine and fluorine. These are accomplished by addition or substitution reactions. Okay, generally they will follow either addition reaction mechanism or they will follow either substitution reaction mechanism. So in general, addition reactions are the type of organic reactions in which only and only addition of a particular group is done or particular atom is done. Nothing will be removed, nothing will be eliminated, but only and only addition is done. And another type of reaction which is known as substitution reaction. So in substitution reaction, what will happen? One particular group or one particular atom will take a place of another group or another atom. So in this manner, what will happen? They both combines with each other, or they both actually, it's basically substituted. So one will be substitute another atom. In this manner, what we will get is basically the substituted product. Okay. So in general, halogenation reaction follows either addition reaction mechanism, either substitution reaction mechanism. Certain catalysts are also used during the reaction, say for an example, activated carbon clays, etc. And they plays a role as catalyst, and they plays a very important role during halogenations. Okay. Now let's begin with the first halogenation reaction along with its mechanism, along with its examples. So first will be chlorination. Chlorination, or the reaction between chlorine and benzene, gives chlorobenzene in the presence of either iron or aluminum chloride. So here the catalyst is either iron chloride or either aluminum chloride, and in which what we will get, the two different substrates are there. Number one, which is benzene, number two, which is chlorine. This type of reaction is known as chlorination reaction. Now let's talk about the reactions and different applications. So the first one, as you can see, what we did is, we have our substrate which is known as CH3, which is ethane. So ethane reacts with Cl2 in the presence of light at 25 degrees Celsius. It will give rise to chloroethane or ethyl chloride. Right? The boiling point of such kind of compound is 13 degrees Celsius. So in this manner, you can see that one H is replaced by one Cl. So H is removed from ethane while Cl will be added to ethane. So here the byproduct which we will get is HCl. Let's take another example. So CH4 reacts with Cl2. We will heat this particular, or we provide heat to the reaction, or in the presence of light this reaction is carried out. At that time it gives rise to CH3Cl plus HCl. So as again H is replaced or H is substituted by Cl, and that another, the H which is removed, that H will combine with Cl. Okay. In our next one, we react, or we have here benzene which reacts with Cl3. So we will take here FeCl3. The temperature range will be 30 to 100 degrees Celsius, and at that time we get chlorobenzene plus HCl. Here also one H from benzene is substituted by Cl, and we get our product which is known as chlorobenzene. Next is toluene. So here toluene will be reacted with Cl2 in presence of FeCl3. The temperature is 25 degrees Celsius. So what we have to do is, here basically one H from the benzene ring will be removed, or it will be replaced or substituted by Cl. So there are two different directions, because CH3 group is ortho-para directing group. So Cl, the first product that we will get here is orthochlorotoluene, and the second product we get is para-chlorotoluene. So ortho-para-chlorotoluene. So we can get that particular one here. Let's talk about the second one, which is known as bromination. So bromination is carried out same way as chlorination. Here bromine water, KBr, HBr are used as brominating agents, and reactions and applications of brominations are as follows. First one, we took here ethene. We have reacted it with Br2 water. So what we will get is 2 H atoms, the bond will be break down and the valencies of carbon will be free. So at that time Br will be added. So this follows an addition reaction and we get our product which is known as 1,2-dibromoethane. Okay. Next one that we have here is benzene will be reacted with Br2 in the presence of FeBr3. H will be removed here and forms HBr, and 1 Br will be substituted on benzene, so substituted by hydrogen, so that Br will substitute hydrogen and convert itself into bromobenzene. Our next example is phenol. So we will react phenol with NaOH plus H2O and Br2 is there. So first we will get para-bromobenzene. When we react it with excess Br2 water, we get 2,4,6-tribromophenol. Let's talk about fluorination. So here F2 gas, HF, metal fluorides, etc. will be widely used as fluorinating agents. As you can see here, we react methane with 4 parts of fluorine. So it's 4F2. It will convert all the 4H are replaced by F2 and convert itself into tetrafluoromethane plus 4HF is there. Then we have ethylene. It's converted in the presence of catalyst in fluoroethylene. We have benzo-trichloride. When it reacts with 3HF, it will convert into benzo-trifluoride. Right? So it's basically a kind of fluorination, that is aromatic fluorination, plus 3HCl. We'll go for further example, which is carbon tetrachloride plus 3HF plus Cl2. So it's basically in the presence of SpCl5 will give rise to chlorofluoromethane plus 3HCl plus Cl2. Our next one is iodination. So the iodination process is different than that of other halogenation process, as carbon iodine or carbon iodine bond is weak than that of other ones, and iodine monochloride is widely used for iodination. So here what we will get is basically ethene will react with I2 and forms 1,2-ethene diiodide. Chloroethane will react with Ki and forms ethyl iodide plus KCl. We have benzene which reacts with 1/2 I2 plus HNO3 is there, converts itself into iodomenzene. It's basically 85% product. And para-nitroaniline reacts with acetic acid and ICI is there. Okay, so at that time it will convert into ortho-iodo-para-nitroaniline. So this is all for this particular reactions. Next we will see in our next sessions. Thank you so much everyone.